Well, hello. Tonight's video is all about your calculator. So, as we said in one of the earlier videos, make like the Roadrunner and go grab it if you don't have it next to you right now. And 99.9% of what we do tonight is going to be all on the calculator and learning some new buttons and some new functions. Specifically, we're going to talk about how to find zeros. It's been a hot topic over the last couple of weeks, and we're going to get into some more complicated ones tonight. We're also going to look at finding the relative maximums and the relative minimums using our calculator tonight. So first things first, before we go forward, it's nice to look back in the rearview mirror and see where we've come from here. And I want to talk about what we're already really good at on our calculator over the last couple of weeks. We've talked a lot about using our shortcut menus. Specifically, we use a lot of alpha F1 and we use a lot of alpha F2. F1, the big advantage there is to use the fractional setup, and when we get into F2, we can use things like absolute values and so forth. And that list will continue to expand throughout the year. We've also talked about storing values. You know, if I wanted to evaluate a particular function at -5, a lot of times it's a lot easier to take that -5 and store it in X, and then just type in the function as I see it on my paper. And then last but not least, we've talked a lot about using tables. Once you type the function into y1, you can always go to the table. The table's great for generating, a table of values where you can go graph the function, and it's also helpful in identifying zeros and so forth. So hopefully at this point you're wondering, what in the world am I going to learn new tonight that I haven't already learned? So the big things for us tonight is we've already talked about using this y equals button, and we've also talked about the table button over here and the graphing button. But what we haven't talked about is those three little rascals in the middle of the top row, and so those are the ones we're going to get into. The second one from the left is your window button. The middle one is our zoom button. And then the third blue one is the trace button, but we're more interested in what's printed above trace, and that's the calculate menu. So it's probably, at least in my calculator, it's blue lettering. So first things first, the window button takes you to a menu like this, and tonight we're going to talk about how to manually make adjustments in my window so that I can either move it to the left, to the right, up, or down, depending on how crazy my graph is. We're going to talk about the zoom button a little bit. We're going to at least flirt with introducing you to it, and we're going to talk about what zoom standard is, and that's probably about it for tonight, and throughout the year we'll talk about some of the other features. But most importantly, we're going to put about 90% of our effort tonight into talking about the calculate menu, which you'll notice if you don't want to hit trace first, you want to hit second, then trace. It's going to take you to what we call the calculate menu. We're going to talk about these first four options: evaluating a value, finding zeros, finding minimums, and finding maximums. Later in the year, we'll do choice 5 there, intersect, and then when you get to calculus, we'll do 6 and 7, where we find derivatives and integrals. So anytime I graph a new unknown function and I don't have a good feel for it, I always hit the zoom button and go choice 6, which is what we call the standard viewing window. Now when you do that, your calculator by default sets your x minimum to -10 and your x maximum to +10, and it counts by, and SCL is an abbreviation for scale. What it does is it counts in increments of 1. So you're going to see a hash mark at 1, 2, 3, 4, 5, etc., for every 1 unit. And then similarly, your y min is going to be -10, your y max is going to be +10, and your scale is going to be 1 again. Now sometimes the standard window works great, and you don't have to tweak it or manually make any adjustments at all. But tonight we're going to assume worst case scenario, and we're going to look at some graphs that by the time you start with the standard window, it's just pure and utter chaos, and we're going to have to make some manual adjustments to get a better window. Alright, buckle up. We're about to dive into our first live example here tonight, and we're working with this f of x function, quantity 3x minus 2 times the quantity 2x plus 5 times the quantity 5x minus 12. And of course you could FOIL all these rascals out, but we don't have to worry about that tonight. We're not going to do that. And if we want to find the following, first of all, we're going to evaluate f of 7/3, very obnoxious value that 7/3 is. Then we're going to find the function's y-intercept. We're going to find all of its zeros. Now remember, zeros is just another word or way of saying find all the x-intercepts. And what we're going to do is we're going to find out that there's 3 x-intercepts on this function. And what you can do is you can imagine yourself, we said we're not going to FOIL it out, but if you did FOIL it, by the time you multiplied 3x times 2x times 5x, you would end up with 30x cubed. That would be the biggest term. Of course, there'd be more terms, but that biggest exponent always tells you exactly how many x-intercepts that we should anticipate. Once we accomplish that, then we're pretty much in the clear, and we're going to talk about how to find a relative max and a relative min. And as we go through these solutions, we're going to round all of our answers to 3 decimal places. Alright, so what I want you to do, if you haven't done it already, is I want you to go to y equals, that's where the party always gets started, and we're going to type in that original function that you saw on the previous screen. And you could use the parentheses exactly the way it was printed on that screen, type it all in, and like we said, by default, I'm going to hit zoom, and I'm going to use choice 6 standard, and here's what pops up on my screen, and I'm going to tell you what, there's no better way to describe it than just saying yikes. This is a very, very poor window. I don't like it at all. I guess the only positive thing is I can see the here's the first 0, here's the second 0, and here's the third 0. I at least can see those. But the downside is I can't see where the relative min is. I can't see the relative max. In other words, I can't see the turning points. And generally, I would just want to I want to kind of enlarge my viewing window here. Specifically, I want to be able to move down. I want to head south, and I also want to head north. I really don't need to move west or east. In fact, if anything, I'm going to move in from left and right. Okay, so first things first. I hit my window button, and I did not adjust the x-min, the x-max, or the x-scale at all. What I did do is I changed my y-min to negative 100. I changed my y-max to positive 100. And I changed my y-scale to 10. And all I did is it just kind of spaced out my hash marks so that I didn't see 100 hash marks piled right on top of each other. Okay? And then what I did is I went and I hit graph. Now this time, when you do that, we do not hit zoom this time. Okay? If we did hit zoom, it would just kind of reset or undo these adjustments that we just made. So hopefully your picture should look exactly what I've got here on the screen. And it's definitely better than it was. For instance, I can see my relative min now, which is a huge improvement, but yet I cannot see my relative max yet. So what I'm going to do is I'm going to go back and I'm going to increase my y max one more time in an effort to try to see that rascal. And what I did this time was I changed my y max to 300. And a lot of times, I just want to be real aggressive and just get to a big number sooner than later. And I changed my y-scale to 50. Now, of all the things we're doing tonight, your scale is by far the least important, but nonetheless, it just kind of makes your graph and axes look cleaner and neater to have those hash marks spaced out. So what you're seeing here is 50s right there. There's 100, 150, 200, 250, 300. Okay, my x-axis I have not touched it once. It's still 1, 2, 3, 4, 5, 6, 7, all the way till we hit 10 here on the outside. And I guess that's what I'm going to adjust right now. Is to me there's a lot of wasted space right here and right here. So what I'm going to do is I want to just chop off these side sections right here because again I consider them to be wasted space. And so what I did here with this last window was I went back in and I changed my y-min to -5, and I changed I should have said x-min, and my x-max was +5, and this is what I consider just a gorgeous window here. Not only can we see the zeros, but we can also see our turning points, and there's really not much wasted space. One more thing I'll say about windows before we jump into evaluating f of 7/3 is that finding a good window it's an art. You'll get better with a lot of practice, and it's just a lot of trial and error. It's not an exact science. It's an art. It's a feel, and you'll definitely get better with time. And the more that you experiment, and probably the more failure that you do encounter, the better off you're going to be. So here's what I want to do. I want to evaluate 7/3. Last week we talked about how we could start on the home screen, store the 7/3 in X and type it in. Today we're going to look at a different option. And the first thing I want to do is we're going to go to the calculate menu, which means we need to hit second trace. Okay? And what's going to happen is once you hit second trace, your screen needs to look just like this. And I'm interested in choice number 1 because I want to evaluate a particular value. In this case, it's called 7/3. So once you hit 1, your screen's going to start off like this in the lower left-hand corner, and it's anticipating that you're going to type a number into this spot right here. And so all I did is I typed in 7 divided by 3, And once I did that, I hit enter, and a couple of interesting things happened. First of all, it converted whoa, don't move it there. It converted 7/3 into a decimal, 2.333, repeating. And then it gave me my y value, and I'm going to round that to 3 decimals, and on a test or quiz, I would report my answer as negative 16.111. The other really interesting thing that it did that's kind of fun is it took the cursor and it put it right on the graph that corresponds to the point they're talking about right here. So this is where x equals 7/3 and y equals negative 16.111. Now, y-intercepts are something that we're going to tackle all year long, and the number one thing that you need to know to find any y-intercept, and it's not just for tonight, but this is true for every function we work with all year, is that we're going to substitute a 0 in for x. So the quickest way for me to do this is to hit second trace, which is going to take me back to that calculate menu, and I want to do choice number 1 because I want to evaluate a particular value. And what I did is I typed in x equals 0, I hit enter, it told me that the y-intercept is 120, and again it put the cursor right on the money and it showed me exactly where that y-intercept was. So hopefully we feel good about that. Okay, of all the things we do tonight, I think that this is going to be the toughest one, and we already talked about how or why we were anticipating that there was going to be 3 zeros or 3 x-intercepts, because we said once I FOILed that function out, the biggest term or the biggest exponent was a 3, so we're expecting 3 roots. Now I'm going to talk about the process that we're going to use to find the very first root right here, which is my far left root of the 3. So I'm going to go back to that famous menu, second trace, take me to the calculate menu, but this time I'm going after option number 2, 0. Once I hit number 2, the first thing that's going to pop up on your screen is this question mark down here in the lower left hand corner, and it wants a left bound. And here's what's going to happen. Like, your cursor may be right here right now when you first got to the screen, and what you need to do is hit your left arrow, and it's going to take your cursor all the way around the horn, and we need to keep moving until we get to approximately this location right here. Now I'm going to let you in on a little insider tip. If you want your cursor to move faster, what you do is you hit second left arrow, and it's going to take a big jump, and then hit second left, and every time you hit second left, it's going to take a bigger jump. But anyway, once you get into this neighborhood right here, I need you to hit enter. Once you do that, you should, especially if you have a TI-84 anyway, it may not do this if you have the 83, but it's going to put this imaginary fence in there, and it's going to ask you for the right bound. And what I did is I took my cursor from here, I hit the right arrow a few times until I was in this neighborhood right here, and I hit enter. So, and then I actually hit enter twice. And once I hit enter twice, you're going to see in the lower left hand corner, your calculator is going to print the word 0. It's going to say x equals negative 2.5, and of course y equals 0. If this doesn't say y equals 0, then we definitely did something wrong. But anyway, you should be seeing negative 2.5 on your screen, and if not, start fresh, go to second calc, and start all over again. Okay, now we did all of that work just to find the very first root, or the first 0 I should say. I'm trying to get in the habit of not using the word root, although it is an acceptable word. I'm trying to use the word 0. But now we got to find 2 more roots, and basically we got to start that process all over again. So right now my goal is to go find what I consider the second root right here. And so I go into, I'm hitting second trace, taking me to the calculate menu. I'm hitting choice number 2. And again, the first thing the calculator is going to ask us for is the left bound. Okay, and I'm going to try to pick out a real fun color here. Now my left bound last time was underneath the x-axis, because technically this point right here was slightly to the left of your 0. But it doesn't mean it's always going to be to the left. And in fact, in this case, when we're talking about my second 0, the left bound needs to be up in this neighborhood right here, slightly above the x-axis. Hit enter. The right bound, we're going to hit the right arrow a few times, and we're going to put the cursor in this vicinity right here. This time I'm going to hit enter twice. At this moment, your calculator should print the word 0 in this corner right here, and it should say x equals 0.666 repeating, which of course as a decimal, or I should say as a fraction, turns into 2/3. Alright, now we still got one more root to go. So we're going to start all over again. It's a long process, but we're going to get faster and quicker at it to the point where it just takes you 5 or 6 seconds to do this whole process. Second trace, choice number 2, 0. I'm going after this root right here. The first thing I need to identify is my left bound. My left bound is going to be in this neighborhood, slightly below the x-axis this time. Hit enter. move the cursor to the right, and I'm going to establish my right bound is up in this vicinity. This time hit enter twice. Again, you'll see the word 0 printed in the corner here, and it should give you about 2.4, I believe, 2.4. Alright, at this point, the good news is you got the hardest one out of the way. We're ready to tackle relative max now, and the best news here is there's only one relative max on that curve, so we've just got to do this process one time. Again, go to the famous calculate menu, and this time we're going after choice number 4. We're going to find the maximum value here. And the first thing that's going to pop up is the calculator is going to ask you for a left bound. Now remember, your max is right here, so you need to pick something that's slightly to the left of that point. And that's why you see my cursor in this vicinity right here. Once you get it in that neighborhood, hit enter. Again, once you do that, the calculator, at least my TI-84, is going to put an imaginary fence boundary line right there. And I'm gonna move my cursor to the right. Boom, 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 boom. Once you get in this vicinity right here, hit enter. And you're probably wondering why I have to do this left bound, right bound process. What happens is later in the year we're going to be working with functions that have multiple relative maxes, and we just need to help the calculator identify exactly which max that we're going after and searching for. Once you hit enter twice, you should see your picture looks like this. You'll know you did it right if you see the word maximum printed in the lower left hand corner. And again, we're looking for 3 decimals right here. Now this is a very interesting rounding. In order to round to 3 decimals, what I'm going to do is I'm going to look at the 4th decimal, which in this case appears to be the 6. And that 6 tells me to round the 3rd decimal up. So I'm going to say negative 1.246 is the x-coordinate of my relative max. And of course, if they did ask for the y-coordinate, we could certainly round that off to 262.346. Here's some more great news. We're going to talk about relative min, and I think you're going to find this very, very doable after we did the relative max. We're going back to the calculate menu, and this time we're going to grab choice number 3. We're going after the minimum, and I bet you can talk yourself through the process. Of course, our minimum is sitting down here, but the calculator first wants to know a left bound. So I'm going to put my cursor in this neighborhood right here, and I'm going to hit enter one time. I'm going to then hit the right arrow several times. That's going to wheel me around to the other side, and once I'm in this neighborhood right here, I'm going to hit enter twice, and for a grand total of 3 times, and then it's going to print in the lower left hand corner minimum, and it's going to tell me the x coordinate. My calculator says that x equals 1.623 is the value of where that minimum is located to 3 decimal places. My 4th decimal place was a 4, which meant I did not round up. I left it at a 3. When it comes to learning new functions on the calculator, there's no substitute for practice and repetition. So we're going to go over one more example here, and I'm going to let you work through the entire process on your own, and I'm just going to post my answers on the next slide, and we'll go from there and see if we're ready for class tomorrow. If we're not quite feeling super comfortable, don't panic. We'll get more practice tomorrow and more interaction. Now, one thing I will point out, the biggest exponent here is a 4. Earlier I mentioned that this exponent is going to tell you how many zeros you have. In fact, I want to clarify that. This number here tells you the most amount of zeros that you could possibly have. You could always have less. So at most, we're going to have 4 zeros. And in fact, something special is going to happen to this graph. I think you're only going to see 2. The most challenging part of the whole process is probably getting a window. It's trial and error. Don't give up on it. Keep experimenting, trying weird numbers, and we'll see if my window is similar to yours. First things first, let's go over our window because everything else is going to be fairly impossible without a good window. Notice I did not manipulate or change my x values at all. I left them at negative 10 to 10. However, my y's, and this took me a while, I started off with negative 300, then I went negative 600, negative 1,000, yada yada. I kept working my way towards negative 2,000. I made my y max 1,000, and I had my scale at 200. Scale is by far the least important part, but it does make the graph look a little cleaner. Well, I'm hoping you hit a home run with these answers here. The values that I got, when I evaluated f of 7/3, I got 195.827. My y-intercept was at negative 56. I had 2 zeros. One of them was negative 7.123. The other one was positive 1.123. I had no relative maxes, and I had one relative min that was at negative 5.106. So hopefully you hit a home run with those rascals, and I will see you tomorrow ready to rock and roll with these calculators.